So here we have an example about a vector projection onto another vector. And we have Ohimba, who's sitting on a sled on the side of a hill inclined at 60 degrees. The combined weight of Ohimba and the sled is 160 pounds. And we notice that we want to know what the magnitude of the force is that Mandisa will have to hold him up on the hill. So let's start with a drawing. And drawings are very useful in this kind of problem. So we have this hill, and it's a 60-degree hill, pretty good size hill here. Something like this. And we have our friend Ohimba. He is up on the hill in his sled here. So here he is on his sled. There's his sled. And let's put him on his sled, ready for a big ride. Alright. And so what we have is Mandisa going to need to hold him back. And we have a force coming down here. And let's call that force F. That's the force due to gravity. Now we're on an icy hill here, so we're ignoring any friction or anything like that. So the gravity's pulling him down. And what we need to know is we need to break this into two components, and we actually just need one of those components. And those two components would give us these directions here. We have the force needed. Let's try a different color with that. We have the force needed here. And that's the force that Mandisa needs to overcome to hold him in that direction. We have the projection. That's the projection of this force onto the 60 degree, which we should label here. Okay. So force F, we know the magnitude of F. The magnitude of F is 160 pounds. Okay. And so we know the direction is going straight down, so that tells us that F is simply 0, negative 160, heading down in the y direction. Alright, so what we want to know is we want to know this vector here, F1. A lot going on here for a little drawing, but let's call that F1 there. So, first thing we need to do is we need to define our vector, a unit vector going in the direction of the hill. So this little vector here, let's call that V. Okay. And so since it's going in 60 degrees, we can simply define a vector as the x-coordinate would be the cosine. That's in the I direction. And the sine of 60 in the j direction. Now notice here that we usually put the magnitude in front here, and we just want the magnitude of v to be 1. So this is going to be a unit vector. You can kind of picture the unit circle if it helps. Well, we know what the cosine of 60 is. That is 1/2 I. We know what the sine of 60 is. It's the square root of 3 over 2j. Alright, so we have defined our vector v, and we also want to note that the magnitude of v is 1. And you can find that by using a little Pythagorean theorem with these two values if you'd like, or again, note that we have a little invisible 1 here. The magnitude is 1 in front of cosine and sine. So we now are ready to go to our formula here for our projection. And what we want to do now is we want this. We know that F1 is the projection of F onto V into the direction of V. And we find that by the dot product of F and V all over the magnitude of V squared times V. Okay? And basically this is just giving us a ratio of the dot product to the ratio of itself. And so this is coming from the angle formula. Alright, and so let's work this out here. Again, we know that the magnitude is 1, so this term just, or this factor, I guess, just disappears. And so we have F dot V. Let's undo that. We have F dot V times V. And so let's take an aside moment here and figure out what F dot V is. Or actually we can just keep it in all together. So F dot V would give us 0, negative 160, dot V, which is 1/2 root 3 over 2. Okay. And we'll multiply that by V in a moment. In our dot product here, we multiply the first components and we get 0. Multiply the second components, we get the square root of 3 over 2 times negative 160. And we're going to add those two products. And in the end, we end up with negative 80 root 3. Okay. Times V. And we'll write V down here. V is 1/2 root 3 over 2. Finally, multiplying this vector, we end up with we have negative 80 root 3 times 1/2, which gives us negative 40 root 3. And then we have 80 radical 3 times radical 3 over 2, which is going to give us 40 times 3, which will be negative 120. Alright, so this, you might notice here, has two negatives. Well, this is actually the force that the sled is pulling down the hill. Mandisa is going to be pulling opposite of this force, so Mandisa's force vector is going to be the opposite of this. So let's call Mandisa's vector M. And so her vector is going to be the opposite of that, 40 root 3 and 120. Finally, the question asked, what is the magnitude of the force required for Mandisa to keep the sled up? Well, we have the magnitude here, and that's going to be the square root of 40 root 3 squared plus 120 squared. And we'll figure out what that is. So this is going to give us radical 40 and we end up with 138.6. And this would be pounds. This will cooperate.
Hey, how's it going, man?
Good.
Made with Doodlecast Pro.